This is the new golden quartz specimen that I acquired, and I'm going to do a specific gravity test to find out how much contained gold is in the specimen. Okay, so here's the tools I feel needed to do this test. Common scale, make sure it's got grams. I put it on a box, as you can see. I got a real, very light yarn. It's ultra light, but I don't like using thread because if it breaks, your specimen breaks. I use a ruler, pretty simple, scissors, and then what you want to do is tie the piece of yarn around the specimen and then around the end of the ruler, as so. Okay, the next task is to zero out the scale. As you can see, it's all zeros, and how I did that was to put the ruler with the string on the scale and then turn it on. As you can see, the specimen is not hanging. It can't hang because then you'd be weighing the specimen too. You just want the string and the ruler, like so. And now it's zeroed out. Okay, the next task at hand is to weigh the specimen. As you can see, the specimen is hanging there freely now off of the ruler, which was zeroed out. So now that that was zeroed out with the string, as you can see, it came to 11.856. That is the weight of the specimen dry. Okay, the next task at hand. We got to weigh the specimen while suspended in water. So to do so, I took the ruler, the string, and hung the specimen inside a little tub of water. It can't be touching the bottom or the sides or anything else. It has to be suspended, which it is. Then, after the scale was zeroed out already, so suspended, it weighs 9.551. 9.551. Okay, time for the math. We take the specimen dry weight, 11.856 grams. Specimen wet weight, that's suspended in water, 9.551 grams. We take the dry weight minus the wet weight equals 2.305. That's the difference. Now we take the dry weight divided by the difference, and that equals 5.1436. That's the specific gravity of the specimen. Now, we take the specific gravity minus 2.63, the average specific gravity of quartz, which equals R, the remainder, 2.5136. So we take the remainder multiplied by D, which was up there, 2.305, the difference, equals remainder 2, 5.7938. Now we take that and we divide that by the constant. This is the number that is always used for the specific gravity test, which is 25.97. And that equals 0.2231 ounces of contained gold in this piece. So we take the contained gold in ounces, multiply it by 31.103, the number of grams in a troy ounce, and it equals 6.94 grams of contained gold in this specimen. That concludes your specific gravity test.